In this tutorial video, we will be explaining how to use the connection feature. This feature can be used to manage how individual customers are connected. For example, you could specify that no cables should be foreseen for a specific customer that won't activate his subscription. Before we dive into the details of the connection feature, let's load in a pre-configured workspace. In this workspace, we have already created the trenches and the crossings. We have also imported a couple of demand points in a single central office location. The first thing that you need to do in order to utilize the connection feature is to create a connection attribute. So let's open up the attribute table of the demand points layer. As you can see, the files that I am using for this demonstration already have an attribute with the correct name. If you are working on your own data, this is most likely not the case. So enter editing mode and open the field calculator. In this dialog, make sure that the option Create a New Field is selected. Set the name of the attribute to be Connection and change the attribute's type to contain textual values. It is best to also change the field width of the attribute. This is the maximum number of characters in each attribute value. You can set the expression for the initial value to null. Now, since I already have a connection attribute in my data, I will press Cancel. But obviously, you would be hitting OK to actually create the new field. Before we continue, let's change some of the visualizations to get a better understanding of what we are doing. To do so, just double-click on the Demand Points layer, and it will bring up the Layer Properties dialog. If we select the Labels tab, we can choose to label each demand point with its value of the newly created connection attribute. On your data, you won't notice any immediate changes to the way everything is rendered. But in the workspace that I opened, you can see that some of the demand points now have a label. These labels represent the 6 values of the connection attribute that are currently supported. First of all, we have the Full option. This basically implies that this customer is to be connected in a regular way. This value is optional. A demand point with no value for the connection attribute would be treated as if it had the attribute set to full. The second option is No activation. In this case, none of the in-building equipment or connection costs will be taken into account. For instance, no customer peripheral equipment will be placed. The third option is No drop cable. On top of not placing in-building equipment, no drop cable will be calculated for this point. Note that a drop duct and the proper drop equipment, such as a drop box, will still be placed in the output. The fourth option is No drop. As you might suspect, in this case, no drop related entities will be placed whatsoever. This means no drop cable or duct and no other equipment. The fifth option is No drop, no disk cable. For the drop layer, this option has the same result as the one before. On top of that, no distribution cable will be placed for this drop point either. The sixth and final option is No drop, no disk. Similar as before, this now excludes both the cables and the ducts of the distribution layer. Now that we know the different options and their meaning, it is quite easy to add some of these attributes to your design. Just select your demand point layers and make sure that you are in editing mode. Then, identify the specific demand point for which you want to control the connectivity. If you right-click on the features for this point, you will have the option Open Feature Form. This brings up a dialog in which you can edit the attributes of this particular demand point. Now, imagine that you would enter an incorrect value for the connection attribute. For example, let's enter invalid. The software will then simply treat this point as if it had the value full for the connection attribute. Let's also change another point's connection attribute. This time, we'll use a valid option. For example, let's enter No drop, no disk cable. It is important to keep in mind that we are changing these attributes in our input data. This actually implies that we are doing some form of input processing, so remember to hit the Process Area button when you are done. And once this is done, let's start a calculation up to the distribution layer to see the effects. For this design, I am using some default rules that place direct cables in the distribution layer. Let's wait a couple of seconds until we get the results. Now, let's take a closer look at the output. We will start with the full demand point. Indeed, we observe that this point has both a drop cable and a drop duct. Moving on, we have the no activation demand point. This customer still has a cable and a duct, but remember that there is no in-building connection costs. This can be verified in the bill of material. Next, we have the no drop cable customer. Indeed, at this location we can spot the drop duct, but a drop cable hasn't been placed. Next up is the demand point with its attribute set to no drop. Here we can clearly see that neither the drop duct nor the cable have been placed. If we take a closer look at the access structure, we can also see that there is no specific drop box structure at this location. Instead, a generic virtual structure has been placed to access the distribution duct, which is still present. Note that these virtual structures will not be counted in the bill of material. If we look at the previous node, it does in fact have a regular drop box in its access structures layer. Moving forward, we still have the customer with the no drop, no disk cable option. Indeed, it is immediately clear that no drop cables or ducts have been placed. Let's also verify that there is indeed just a distribution duct, but no cable for this particular drop point. And finally, there is the no drop, no disk demand point. It is again straightforward to spot that this location doesn't have cables nor ducts for either the drop or the distribution layer. Now let's also take a closer look at these 2 points whose connection attribute we updated previously. The one with the invalid attribute has simply been ignored and was treated as usual. For the no drop, no disk cable customer, we can quickly verify that no drop equipment was placed. Interpreting the distribution cables might be a bit more complicated. If we check the distribution cables running in this particular trench, there are in fact 2 cables there. However, both of them are serving one of the other drop points. So, as requested, there is indeed no cable for this particular customer. One last thing to which I want to bring your attention is related to the feeder layer. If we take a look at the size of this distribution cluster, we will notice that it still has the complete home count. This implies that sufficient feeder fibers will be foreseen to serve the entire cluster. This includes even those demand points that are currently not activated. That way, the network is still future-proof in case some of these customers would end up activating their subscription at a later time. This concludes our tutorial on using connection attribute. For specific requests about custom options to manage the activation of individual customers, please contact ComSoft.